So let's go. Just give me a second. Okay, all right. So there you go. Yeah. So PED. So here, this is my question: which demand curve is elastic, and which one is inelastic? Yeah. So can someone just answer me the question? Yeah, which one is more elastic? Which one is less elastic? Okay, bottom is more elastic. Inelastic is the steeper one. Okay, so yeah. So here, look, for the XL classes, we will learn a little more about PED. So this is one thing that we need to realize for one usual demand curve when we try to look at PED is that they both have elastic and inelastic portions. Okay, all right. Yeah. So you see here, economic. Yeah, yeah. So from here, I know it feels confusing. All right, but this is what economics is. Okay, you can imagine economics is like a puzzle. Yeah, a puzzle, a very big puzzle. And when you are doing that puzzle, yeah, along the way, you will see so many missing pieces. Okay, yeah, like maybe around different puzzles and yeah, in some other places. So you never know what you are actually learning until you get all the puzzles together and you are able to see a rough picture of what the puzzle is all about. Yeah, but at the end, when you get everything together, well, maybe not everything together, maybe some more things together, you will see. Look, maybe the picture that you thought you knew wasn't the one that they are showing. Yeah, they're actually showing you something else. So economics is really like bizarre adventure, I would say. Yeah, we're talking about bizarre adventure. You guys watch JoJo? No, I'm just saying. No, I know. Maybe I'm a bit, much of a nerd over here. But look, because of the shutdown and everything, we could not go to school. I just somehow got into the JoJo anime series. Look, I know, yeah, I'm pretty much of a nerd, but you got nothing to do, so I basically watch everything. Yeah, like yeah, anything. Yeah, but that one is really good. So I suggest you guys, if you have time, go watch it. Okay, I really like the art style, and it's very funky and groovy sometimes. Yeah, I watch everything, so you know how much time I spend on anime nowadays. So, well, anyways, okay. So yeah, economics, just like that, is an adventure. All right, and now Look, basically, it doesn't really matter about the slope. They all have elastic and inelastic portions when we talk about a normal demand curve, like one of those. Okay, so now let's do some calculation and see why that's the case. So now I just want you to calculate the PED for these 5 points. Okay, yeah, from F to E, from D to C, C to B, C to A, and B to A. All right, so I'm gonna give you 5 minutes to do so. Okay, and then we'll check the answers, and you will see something interesting. Based on the answers that you just calculated, what can you tell us from this demand curve? Do you see any pattern? Do you see any trend? Anyone? Uh, Decrease. Okay, that's one word. Yeah, can it can it be more in detail? It starts to become more inelastic. Oh, okay, all right, yeah. So altogether, yeah, it becomes better, right? Yeah. So there you go. Okay. So like we mentioned from the very beginning, when you talk about just a normal demand curve, you always have an elastic portion and you always have an inelastic portion. Okay, and from the upper portion of the curve, you see the elastic portion, and from the lower part of the curve, you see an inelastic portion. Okay, so which means that for this curve here, for this line here, when we get to PD, which is equal to 1, that's the midpoint. Okay, that's when we are in the middle. Does it make sense? Yeah? Okay, so yeah, like that. Okay, all right. So here, well, that's your midpoint. Okay, in the middle. All right, yeah. Look, you might be wondering, like, so why do we look at different slope, yeah, to determine the PED? Well, I'll answer that question later. Okay, but now let's just focus on the new concept that we are learning from a PED, and we will do some more study. All right, okay, all right. Yeah, so here, look, the second thing that I want you to do, okay, I want you to calculate the total revenue from A to F. So I want you to calculate the total revenue for point A, point B, point C, point D, point E, and point F. Okay, oh, Bryce is here. Hi, Bryce. So yeah, total revenue should be easy and quick. Yep, are you all done? Yep, cool. All right, so let's check the answers. I'm not going to ask people because this is just too simple. All right, so check the answers here, from here, this table here. Check the answers. And what do you observe from the total revenue table? What do you observe? So increase, then decrease, and okay, and maximize at C. All right. Can someone else tell me why this is the case? So now you want to explain it. So why? Okay, so you can see this, right? Increase and then decrease and maximize at point at the midpoint. So can someone else explain why that is the case? So how do you explain it? Yeah, I mean, just use your own interpretation. So you can actually use what you have learned so far for PED to explain this. Well, let me. Okay, so let me just ask some people, I guess. Isaac. So tell me, how do you how do you explain this? So it will, the total revenue will increase then decrease and maximize at point C. How would you explain situation like this?
Because if it's too elastic, then people may not buy it at the top. That's why revenue is lower. At the
Uh,
middle, it's unitary. So
okay. But
wait,
can you tell me, like, if you started from the top here, why when the price is decreasing, the total revenue will go down? It will go up. Yeah. So let's start it from the top here. So why when the price is going down the curve, the total revenue will go up?
because quantity demanded will go up.
Go up. What do
Like
you
if you're at 50, then it'll be zero.
Yeah, but the quantity demanded would go up, but can you make it more specific when you go down the curve? So based on
Then quantity transacted will go up as well.
oh, okay, okay, okay. Okay, thank you, Isaac. Yeah. So from Percy, is it because when PD is 1 is unitary? Yeah, of course. When you get to point C is unitary. Okay. Yeah. But the thing here is, look, it's just normal interpretation from the PED that you have learned. Okay. When you are at a point which has a high PED, okay. So when you lower the price, you will see a way bigger change in your quantity demanded. And that is why when you lower the price, so here when you go from 50 to 45, when you are in the elastic portion of the demand curve, look, the quantity demanded will have a way bigger change. Okay, so so that's why when you decrease the price, the total revenue should be higher within the elastic portion of the demand curve. Okay, until you get to point 1. Okay, it's more like a neutral point right here. Okay, so right after point 1, you will get yourself into the elastic portion. So if you keep reducing the price, and what will happen. Yeah, because when price is changing in the inelastic portion, you will have a smaller change in your quantity demanded in terms of percentage. Okay, yeah, we just have to go back to what we have learned so far. So, if you just keep going, if you just keep reducing the price, even when you are in elastic portion of the demand curve, look, the total revenue will go down. Yeah, does it make sense? Okay, so if you go beyond 1, yeah, you go, to the inelastic portion and you still decrease the price, look, total revenue will go down because we know, look, when you are in the inelastic portion, it's better to increase the price in order to get more total revenue. So if you, turn this around, if you start from here, start from 100 here, okay, if you, so let's say you start from A, right here, okay, yeah, so you will see it's the same. When you increase the price, when you are in the inelastic portion, your total revenue will increase as well, okay, until you get to point 1. Okay, well, I mean PED is equal to 1, yeah, point C right here, okay, all right. And then if you keep increasing the price, when you get to the elastic portion, if you increase the price, what will happen. Okay, the total revenue will go down because of the elastic nature. Okay, does it make sense? Yeah, so if you are trying to explain this curve here, explain it this way. All right, okay, yeah, you just have to use the same knowledge that you have learned so far for PED to explain one demand curve. Okay, different PED along the curve. All right. So, any questions so far? Any questions? Yeah, just feel free to ask if you have any questions. Oops. I think I got the wrong thing here. Am I able to copy this to a Jamboard? Let me see. But not really. But I would like to copy this to a Jamboard. Okay, so let me just crop this real quick. Yeah, my computer is so slow. It's time for me to change another one. Okay, fine. Right. Yep. And just give me a few more seconds. Okay, so now we know, look, along the curve, you will see different levels of PD, right? Okay, so it's not really just restricted to what we had learned so far, something like this. Okay, so when the slope is steeper, then we call that inelastic, and when the slope is more flat, we call that more elastic. All right, yeah, because all the PEDs they are within one single curve. All right, yeah. So now, what about here? I want you to well, I think I'm gonna share the link with you guys one more time. Yeah, just give me a second. It's loading. Okay, yeah, right here. Okay, so yeah. Wait a second. Well, you don't need to go in. Well, some of you might want to go in because I'm gonna ask questions. So, what is the PD for this point then? For the red dot over here. Can someone do the calculation for the PD here? On a Jamboard, like right here. Yeah, can someone just do it for me to show the people? So if I'm trying to find the PD for this point, what is it going to be? Or do I just have to ask people to do it? Well, I think it's quicker to ask people to do it. Yeah, okay. Charlotte, can you help me? Yeah, so what's the PD for this point? Well, let's call it G. Okay, let's call it G. Can you do it here, Charlotte? Can you just do it on a Jamboard? Yeah. Oh, 0. Can you give me the working as well, Charlotte?
I'm not quite sure.
You're not quite sure? Okay, alright. Okay, alright. Anyone would like to try it? Look, it's just, like a normal... Okay, someone is doing it. Okay, I think that's undefined. Okay, alright. Yeah, so there you go. Undefined. Right. Okay, thank you, Katrina, over there. Well, but, I guess I'm going to go through this one simply. Okay, well, you just have to use the normal way to calculate the PD for this one. But look here. Okay, we just have to go back to the old school equation. The percentage change in quantity demanded over the percentage change in price. Okay, so we just have to find one particular point to get reference. So let's say we are going from G to F. Okay, yeah, but because we are starting from here, so we are actually looking at this point. So if we're going from G to F, okay, so for the quantity is going from 10 minus 0 over 0. Okay, yeah, over when you talk about the price, okay, it's going to be 45 minus 50 over, sorry, yeah, make it, wait, no, got it right, yeah, 50, right here, okay, alright, yeah, so there you go. So, when you look at the scale here, 45, 50, so that should be a 10%, yeah, and minus 10%, because, here is minus sign, so 10% right here, yeah, cool, alright, yeah, and then, 10 minus zeros, so it's 10 over 0. Okay, if you use your calculator, if you use 10 divided by 0, you should get something like undefined or error. Okay, do you know the reason why it is an error if you are using anything divided by 0? No, I know, yeah, but it's part of this chapter here. I'm just trying to get you to understand it. So if anything divided by 0, why, when you're using the calculator, it is showing error? Yeah, it gets towards infinity. Okay, yeah, okay, alright. Yeah, error. Look, infinity is never a number, I would say. It's only a concept. Alright, and that's why your calculator cannot comprehend, okay, yeah, like what's happening there. Alright, so that's why it's error. Okay, alright, so anything divided by 0, you will get infinity. Okay, yeah, like that. Alright, so if you're using infinity, okay, over anything, which will give you infinity. Okay, alright, so that's why for G, that is having a PD of an infinity right here. Okay, alright, let me just clear that. Make it, okay, equals to, yep, like that. Okay, alright, yeah, cool. Okay, so yeah, so you will see all the PD, all the possible PD can exist in one curve. Okay, yeah, just one curve. Along the curve, you will see from infinity, the elastic portion, and then you will get to the midpoint, and you will get to the inelastic portion. So you would know, look, for this point here, let's call that, H. Alright, if that, you know what that is based on, the logic here. The PD is going to be 0 for H. Yeah. To be 0. Okay? Yeah? Alright? Okay? Yeah, so if you are trying to start from here to any point, let's say you are starting from this point here to a point A, okay, you will also see something similar. Okay, so point A to point, so here for your Q, the percentage change of Q, so it will be AT, minus 100 over 100. Okay, and then for this one, for the P, you will find 5 minus 0 over 0. So we know that anything divided by 0 will give you infinity. Okay, and now we just need to know anything divided by infinity will be equal to 0. Yeah, you can imagine, something is divided by something so big, so huge. It's like, as big as the universe. Yeah, so you can imagine it has to be something so small. All right, so it's 0 right here. So you can, you can use this logic here to see. Look, G is going to be infinity and H is going to be 0. Okay, all right, yeah. So there you go, right? So you can find all the numbers that you want within one demand curve actually. All right, yeah. And when you are okay, all right, yeah. And when you are trying to find the PED for a particular point, yeah, you just have to focus on where it starts from. Okay, so when you look at 3 and 4, yeah, it is starting from C to B or C to A. Well, but basically you are trying to look at the PED for C. Okay, so it's more important to look at where it started. Okay, where it started right here. Okay, all right. Yeah, so there you go. Okay, all right. We still have like I think 20 minutes. Okay, all right. So any questions so far? If there's not, okay, I think I'll give you 5 minutes. Okay, I'll give you 5 minutes. Can you explain? Yeah, I just want you to explain why PED changes along the demand curve. So if there's a question here, it asks you why PED changes along the demand curve. How would you explain it? How do you prove it? Yeah, like in written words. Okay, so I'm gonna give you 5 minutes. You can play around with the equation and put some numbers into the equation and try to come up with a written explanation for that. Yeah, sometimes you do see that kind of question in your exam. Okay, so yeah, I think I'm gonna give it 5 minutes. Try to explain it. All right, yeah, and for Katrina, I think you can just take a short break since you have already proved it. All right, like way earlier. Yeah. So don't answer the question, please. I'm just gonna let the other people answer that. Yeah. So Percy, I think you have done a great job. Okay. So if you look at Percy's answer and you are able to find a transition. Okay. Yeah. So from the top, yeah, from Percy's answer, look at high prices and low quantities, the percentage change in Q is relatively large. And if you look at the other side, it's the opposite. So based on law of demand, and you will see when we go down, okay, this one here, the percentage change in price is going to get bigger and bigger. Okay, whereas the quantity is going to get smaller and smaller. The percentage change in quantity is going to get smaller and smaller. That's the trend. Okay, if you put the both, yeah, the transition in your equation, you will see that's why look, it will start off with a big number and it goes down and down and down until it's 0. Okay, all right, yeah. So there you go. Yeah, you can explain it this way. So Percy, yeah, good job over there. All right, or you can just change the equation a little bit. Here I think. Yeah, because the other day I was doing revision with my year 12 and we came up with a question similar to this. So yeah, I think I did something. Oh yeah, I did something here. So you can take a look of yeah, I know it's a bit messy here. So when you look at the equation here, so this is the PED equation that we have. So if we just adjust the positions a little bit, Okay, so it becomes something like this. All right, yeah, we just have to change it. Yeah, put this on the right. Okay, and if we just switch the positions a little bit more, you will see this. You will see this one here. I'm gonna use the blue color. Yeah, so this one here. Yeah. Forget about the words here. Okay, just look at the equation here. All right. So you will see something very interesting once we have get to this position here. Okay. Yeah. So you will find that when we are looking at this one here, QD2 minus QD1 over P2 minus P1. So that is basically the slope of that curve. Yeah. But you might ask, hey, but wasn't it like rise over run? Yeah, the usual way that when we do mathematics, we did that. But if we get to a more specific way, yeah, when we are looking at a slope, yeah, what is the equation of a slope when we look at it in general? So how would you say it? Yeah, how would you how would you say the equation for a slope in general if you are not using rise over run? If I give you okay, all right, okay, all right, but yeah, so nice one over there. What if I give you two words, dependent variables and independent variable? How would you use the two words to define a slope? Dependent variable and independent. Okay, Tom. Yeah. All right. Yeah. So very good, guys. Okay. Dependent variable over independent variable. So we have two variables. Yeah. P, Q. In economics, which one is the dependent variable? What do you think? Yeah, Q is always Q, right? Yeah, because we always look at when the price is changing, what will happen to the quantity of something. All right, so Q is always the dependent variable. So we are going to use Q over P to find that. All right, does it make sense? Yeah, because when that guy, Marshall Alfred, when he developed, like demand and supply, he kind of looked at the curve like upside down. Okay. Yeah, so that's why when you try to study more of economics, you will find the linear equation of the demand curve is a bit different than the one that we have learned in mathematics. But they're actually the same. Okay, they are different, but they are the same. All right, but you just have to look at it like upside down, and it would make sense. But when you make it more technically, it's just using dependent variable over independent variable. And that's why you will see the slope here. So when you are seeing a like a constant slope in your curve, right? Because it's a straight line. Okay, so you will see. Look, if this one here is constant, is constant. This one here is constant. So you just have to plug in different price and the related quantity demanded so that you can find the PED. And to me, this one here, this equation here, makes more sense. Yeah, it looks more simple to understand the PED along the demand curve. Because for this one here, look, the slope is constant, and when you just put, when you're just using law of demand, when the price is low, quantity demanded will be high because they have a negative relationship, right? So the number should be pretty small if that's the case. Yeah, when the price is small, and that's why QD is high. All right, but when you have the transition, when the price is getting bigger, then your QD will get smaller. So your number will get bigger and bigger, bigger and bigger, bigger and bigger. Okay, so this is how you can explain it as well. All right, yeah. So you can explain it this way. You can explain it like what Percy did, yeah, or you can explain it, another way, yeah, like Tom did. But in the exam, the examiners they prefer more of a mathematical explanation over here. Okay, all right, yeah. So I would say this one here is pretty good for explanation. Okay. So from this, equation here, the PED changes along the demand curve, for sure. If that is a linear curve, all right. So if you now know this is the variation of this equation of PED, then the unitary demand curve that you have learned will make more sense right now. Okay, if you go back to wait, give me a second. Where is it? Nope, it's not here. Well, let me just open that up. Just give me some time. Okay, so when you look at this curve here, yeah, because you see it's non-linear. Okay, so with that being said, look, when things are changing, the slope is also changing as well. So when you go back to this equation here, yeah, so which shows when this one here is changing, the slope is also changing. All right, so at the end, which means that, look, at any point of this curve, the PED is always 1. Okay, if you are showing it in a non-linear curve. Okay, at any point in this curve, the PED is always equal to 1. All right, so that's why this is one special case. Okay, well, of course you can also find when PED is equal to 1 in a linear curve, in the midpoint. But when you want to show a constant constant change, then this is the way to do it. Okay, all right, yeah. Well, you don't need to know that much for this curriculum, actually. Okay, but trying to make you understand more why this is the case. Okay, all right, yeah. So when you look at this one, yeah, all the points, they are all equal to 1 in this case. Okay, all right, yeah. Not gonna go too far. All right, yeah. But at least you need to explain why PED changes along the demand curve. All right. Yeah, and if you're interested, you can look at the economic way to make a linear equation, in your free time. Yeah, and you will find something interesting as well. Okay, all right. Yeah, I think I'm going to stop here. Well, yeah, look, here I just put the way that I change the PED equation in the PowerPoint, so you can take it as a reference. Yeah, if you forgot to mark that down. All right, so it's just the same. Okay, yeah. Yeah, okay. So in the SL we learn about the curve we have for 0, infinity, and also 1. Look, that's why they are the special cases. They are the special cases. You can always find 0, 1, and infinity within one linear demand curve. Okay, one normal demand curve. So the 3 special diagrams that I show you, that is just for another case. Okay, all right, yeah, just that. Okay, all right, you guys feeling all right? Yeah, you guys feel good? Yeah, I mean, for some of you, we might want to go back and digest a little bit, for this part over here. Okay, yeah, it's fun part. Yeah, all right. Yeah, I think I'm gonna stop here. And well, like I said, I will not give you any homework for this week because I still have a lot of tests to mark. Yeah, and I haven't checked on your homework yet. So let me finish the test real quick, and then I'll check on your homework, and I'll give you some new homework. All right. Yeah. So if there's nothing else, then I'm just gonna let you go. All right. Okay. Yeah. Okay. No questions. All right. I'm just gonna let you go. Bye, guys. Bye. I'll see you guys tomorrow. Yeah. See you guys tomorrow. Bye. Bye. It's gonna be tough in the first period. Yeah. I'll see you guys. Tomorrow.